Morning, Sagar.
Hey, good morning, Vijay. How are you?
Hey, I'm good. Thanks for joining the session. Good morning, guys. Thank you for joining the session on time. So today, I think we are good to start. We have Sagar with us, Sagar Davda. To give you a short brief about him, he's a data scientist in Episodes LLC, and he's also a Grey Atom alumni from 2017. So, guys, today's session is on data science project cycle and the stakeholders. So it's basically to give you a glimpse of how real world data science project works, and who are the people involved, what are the teams, what are their roles. So Sagar is going to take you through a very cool session, in which you will get a good glimpse of the real world. And to make the session more interactive, feel free to ask questions to Sagar wherever you feel you have a query or doubt. You all can unmute yourself whenever you want. In the end also, I think we'll have a good 10-15 minutes for Q&A. Sagar, I think we are good to start now.
Okay, perfect. Thank you, Vijay. Hey, good morning, guys. And first of all, thank you so much for joining at 8 a.m. on a Sunday morning. Okay, it means a lot. The climate is pleasant. The weather is so beautiful. I personally would have loved to get a sleep of more than 12 to 15 hours. I normally do on Sundays. I'm pretty lazy after a heavy dinner, obviously. But I guess this really shows that you are so serious and so committed towards this entire project. Good move, guys. Good move. So let's get started. Just give me a second. So today's session is all about the life cycle of a data science project and dealing with stakeholders. I'm just curious, how many of you guys have attended my previous career services session before? Anyone out of the existing participants? Yes, Rohit, you have. Yeah, I remember you being there. What about the others? No? Okay, okay. Most of them haven't. So Rohit, you're going to. Okay, yeah, Arun. Yes, yes. I remember Arun and Rohit. So you all will hear quite a few of things which I normally tell during my career services session. But again, I'm glad that you all are a part of it because going over these things, reiterating them is only going to, uh, make these things stick in your brain, and I hope that you'll follow it and you'll like it. So I'm going to start sharing my screen. Just give me a moment. So is this presentation visible to everyone? Yes. Can I get a quick yes?
Yes, Sagar. It's visible on the screen.
Perfect. And am I audible enough? Is the voice
Yeah,
quality
yeah,
fine?
yeah. Yeah, the voice is good.
Yeah.
Okay, fantastic. So I'm going to hide my chat box for a while, and whenever I will keep checking the chat box in a while. Okay.
Cool. Yeah.
All right. So here is a quick introduction about me. I am Sagar Dauda and I work as a data scientist three with Episodes India. We've got hierarchies in our company starting with associate data scientist. Then you have a DS1, DS2, DS3. So this is my third year with them. I started off as a data scientist one, and now I'm a data scientist three. So, like Vijay mentioned, I was a part of the 2017 alumni. In fact, the very first student in Grey Atom. Okay, so I had transitioned from a non-data science background to a data scientist. Okay, now this is one line that I really want you guys to look at. I'm an applied data scientist. Okay, I call myself an applied data scientist. The reason being, uh, this field is so vast and ever changing. Okay, and the changes are also pretty rapid. Now there will be instances when you will not be aware about everything, and a different question will be thrown to you where you will have to take an approach which is going to be unexplored so many times. So what do? You can't wait for 6 months to understand the theoretical concepts, practice it, and implement it, right? So I focus a lot on applying the data science knowledge that I gain, and try to make a meaningful product out of it. Okay, more than meaningful, it has to be user friendly, something that my user wants. I work always on the basis of intent. My total work experience is around 10 years. Okay, and most of it has gone into designing and deploying solutions and dealing with people. So when I say designing and deploying solutions, except for episodes, I have not done data science anywhere else before. a little bit of data analytics after I started learning data science in Grey Atom. Uh, but yes, again, I was there when it came to designing solutions. So I used to design solutions regarding the storage, the servers, and the backup software. So I used to design how will it work? Will your data flow over the LAN or will it go over the WAN? How many number of intermediate nodes would you require? And what is the optimal number of backup that the client should be having? Depending on their retention strategies, I used to uh, decide what are the different kind of devices that a client should be focusing on, whether it has to be a tape based backup or whether should it be an appliance based or a disk based backup, so on and so forth. So that brainstorming part was always there with me, and this is what I used to my advantage, guys. So when it came to the interviews, there were a lot of companies who had this resistance in hiring me initially, because they wanted someone who understood the theory pretty well. Okay, and I'm telling you, the companies that I'm talking about, even they were new to what data science is. Okay, but overall, if you look at this term data science, it is all about dealing with this first word data. Okay, and science is all about experimenting. But in the end, okay, let's say COVID-19 is one situation. People apply a lot of data science. They're collecting data from the existing people who are affected. They're applying a lot of experiments on it in order to develop a vaccine for it. Okay, so if you have the data with you but you're not able to develop something out of it, or you are developing something which satisfies your intellectual curiosity but people can't use it, it's going to be a complete waste. Okay, no one will accept your solution. So whenever you are working on a data science project, two things that you have to be absolutely clear about is what is it that your user wants, the end user, someone who's going to use your product. What is it that he, she, or they expect? And second is you ensure that whatever you're building is user friendly and deployable. When I say deployable, let's say if you're working on a prediction data, okay, you have to predict something. um, for example, a loan application. You may be working for a bank. Well, the banks give you a set of information that this is the age of the customer, this is the past civil score, these are the past settlements, these are the past current these are the past accounts that were settled properly, these are the current active accounts, this is the total debt, so on and so forth. So now, on the basis of that, if you build something which is too complex or something that takes a lot of time for the data to be processed and gives you an outcome may be very good. But let's say if it takes 5 to 7 minutes for an application to be processed, okay, people will refrain from using it. So when I say deployable, you have to take care of the overall performance in terms of maybe accuracy or precision, whatever metric you decide on, the scale of the deployment as well, and the user friendliness. Okay. Now you will obviously have a team of data engineers to help you do this, but that requires constant collaboration with the external team as well. Right, so what I want you guys to focus on when you are learning as well is to be good applied data scientists, because out of all the jobs available, 99% of the jobs will be around this applied data scientist role, and there will be few research related roles. All right, and research related roles are normally with giants like Amazon, Facebook. I guess even Reliance has started accepting this bit of research roles. Or if at all you are a PhD candidate who's being sponsored by some organization to do a research in their field, right? But most of the openings are going to be in and around applied data science roles. So that is what you should be focusing on when you're learning as well. So you get into that habit and you get into that groove. Okay, so we're going to talk about the life science of a data science project. There is a nice reference material given, a Medium blog. I will share this link with you later, and in fact, we'll go through this later on. First, I'd like to talk about the kind of experience that I have been through, and I want you guys to take the first-hand benefit of it. Right. So when I say applied data science, is this term clear to you guys? What applied data science is and why should you be focusing on it? Is this concept clear to you guys?
Yes, yes.
Okay, perfect. All right, this is what a general data science project flow looks like. First thing is business understanding. This is very critical because here you will interact with the stakeholders for the first time on a given project. So this is when you will understand that what is the business challenge. Okay. Now mind you, not the objective. I'm talking about the challenge that the business is facing. Second is what is it that they're trying to achieve. And then based on that, you will arrive at a well-defined data science problem. So now let me tell you how this entire cycle works. This specific part itself is a bit time consuming. So I'll tell you history about the way we work at Episodes. So the NLP in the data science division in Episodes started in 2017. Okay, a year before I joined the company. So when this division was formed, management had one challenge, that is the time taken. So what we do is a lot of medical coding. So let me also give you a bit of background about my organization, so that will clarify a few things for you. So we have a team of medical coders. Okay, what medical coders do is they look at the patient's report, and then they identify what are the diseases present, they confirm if the disease is valid, and so they look if there are any related lab tests, or is this disease currently active, or was it just a past disease. So they look at many other factors, and then they capture a code for every disease. That is called as medical coding. So this entire coding details is used by insurance companies to settle the claims and also claim a bit of reimbursement from the government. So that's how this cycle works. So when this data science division at Episode started, business had a challenge that the overall time taken by the coders to process charts is pretty high. We need to lower that time, and we need to use NLP. So there was one problem that they, or rather, one thought that they want to lower the overall time taken to process the charts, and they also wanted to use NLP. Now, using NLP is a pretty vast and very vague statement. Okay, so we had several interactions with the stakeholders, and this was done by my boss, obviously. So at that point, his stakeholders were directly the CEO and the COO. Okay, and mostly you will have people at the C suites who are going to be setting the objectives for you guys for data science, because whatever you do in data science is directly going to impact the business. For a services based organization, this is most likely going to be your clients, and again the clients are going to be either the project managers or maybe the CFOs or CTOs of the other organization. You will normally deal with leadership, and when you deal with leadership, guys, you have to have a structured approach. Okay, I cannot emphasize more on importance of having a structured approach and a proper communication. So during this business understanding phase, we first ask that when you say reducing the time, what is the expected time that you're trying to reduce? Are you trying to, so if a chart takes 10 minutes to code, what is it that you're trying to achieve? What will be an acceptable time reduction? So 9 minutes and 50 seconds is definitely not going to be acceptable. So the initial assumption, even the management did not know, but they said we would love to see a close to 3 minutes reduction. So they were looking at a 30% time optimization in the beginning. Okay. And then the other question, we have to use NLP. NLP is pretty broad subject, and using NLP means a lot of things. Now, what about NLP? How do you use NLP? So this is where the brainstorming started. So we first made the CEOs and the COOs explain that what are the options available with NLP. So with NLP, there are certain things that you can do. For example, there is a name entity recognition. Okay. When you start studying NLP, you will realize there is something called as pause tagging as well. So you pass a sentence, and the pause tagger will tell you this is a noun, this specific word is an adjective, this is an adverb, so on and so forth. Okay. The broad concept is called as name entity recognition. So when you pass a sentence, it will identify the things that you have trained. So let's say you pass a sentence called as Apple's share rose by 330% today because of the overall economic conditions. So here the Apple is not a fruit, but it is an organization. So in this sentence, Apple is an organization, and it will identify Apple as a organization. So that is name entity recognition. You have a word. What is that word? Is it an organization? Is it a country? Or is it something else? So we first identified there was a need for us to build our own name entity recognizer, which was supposed to be used for medical, or rather a clinical domain, healthcare domain. And then after we did that, we had to capture codes. So trying to convert, or rather automatically find the most probable code for this. So that is when the overall concept of building a custom search engine for these medical terms came into picture. So these were two small components that we started with, and today we've got around 12 components in production, 12 different things that we do related to NLP and data science in production. But this entire business brainstorming took about around 1 to 1.5 months. Okay, so it may sound pretty simple the way I've put it across in a summarized manner, but this is a very intense session. So in the beginning, at least, you will have to spend more time in business understanding. There will be a lot of questions thrown to you. There will be a lot of questions that you should be asking the stakeholders, and then you should unanimously come to a consensus about what is it that is going to be done, and that has to be accepted by the business stakeholder. So this is an extremely critical part. The next thing is the data collection. Okay? You cannot do data science without data. So after your business objective and your data science problem is clear to you guys, you have to focus on data collection. Now, if you're lucky, okay, if you're working for an organization who has that data culture. When I say data culture, they log everything, they maintain data for a long time, they have got a good amount of historical data, or at least they believe in keeping a historical data. So you just have to collect the data that is stored in the past. But let's say what if the company is new and the company doesn't have much data, or rather the data culture did not exist till date, and now you are going to bring in some changes. So in data collection, there are two questions. First, is the data available? If not, then what is the external data source that you can rely on right now? And if the external data source is also not limited, how do you generate the data internally? That's a question you have to solve. And once you have the required data, then you should start looking at how will you collect the data for data science. So we deal with a lot of PDF files, right? Now PDF files cannot be directly passed to any natural language library. So we have to convert the PDF into text. So we use an OCR processing wherein the PDF is first converted to an XML, and then from XML we extract the text, and then we have our own custom sententizer and tokenizer, then, which is passed on to our system. Okay. So you have to ideate the strategies around how the data collection will happen. Now, data collection also cannot be manual. So let's say there is a specific place. If you're dealing with structured data, a lot of your data will lie in a database. Now, you can't just manually pick up the data every time. This entire strategy has to be automated. Okay, you'll have to create a pipeline. This is where your data engineering team will help you, but there has to be some kind of an automation. So, as and when the new data keeps coming in, you start processing the data, and then you keep updating your models with the new data that will come in. So, this is the next step. And after you've collected the data, data understanding. Okay, data understanding is all about understanding the business. Now when we say data understanding, you don't just look at what is the data type, whether it is an integer, whether it is a string, whether it is a list or a dictionary. You are referring to what is it that the data is trying to tell you about the business. Data understanding, a large part of this is exploratory data analysis, wherein you try to explore the data and understand what is it that this past data is telling you. Okay, I'm going to unhide my chat box and ask you guys a question. Let's say I give you three rows, okay, three columns. Column one says, column one is about the age of a person, column two is the height, and column three is the weight. So if I tell you there is a person who's 22 years old, whose height is 5 feet 3 inches, but the weight is 124 kgs. Okay. Now column one is the age, which is an integer. Column two is a float. Column three is also a float. Understood. But what is it actually trying to tell you? So you guys can tell me when someone says there is a person who's 27 or 23 years old, the height is 5 feet 3 inches, and the weight is 120 kgs. What can you understand from this? BMI, absolutely very nice. Yes, yes, you can calculate BMI. Overweight, very good. Energy. Exactly. This is what it is. The person is overweight. The person is at a risk. Absolutely, Karthik, you hit the nail on the head. The person, because of obesity, may be at risk to some kind of a kidney disease or maybe a cardiac arrest, because this is what happens when you're overweight. Okay? Obesity. Yes, absolutely. So this is what your data will tell you about. So then you can quickly profile that, yes, if I have certain people like this, then I may have a set of people who are obese or overweight. So if you were an insurance company and you wanted to calculate premium, so you will have additional or surplus premium for people who are obese and are at a risk of such fatal diseases. Yeah, absolutely, Ramesh, not a normal data. So your data understanding will take up quite a bit of time. So for any project that you are working on in data science, my approach in specific, okay, this piece of data understanding, this normally takes around 40 to 50% of my overall time in the project. Because in data understanding, what I do is once the data is collected, I do a lot of EDA on it. I understand the data and this specific set of problem very well before moving into the further steps. Because the more understanding I have about the data, the more sense it will make to me when I work further on it. And without understanding of the data, we may take a random path, which might or might not be correct. All right. So if you ever have to come back to this because of a wrong outcome, then that's a bad sign of planning as well. So your data understanding has to be thorough. So you can do EDA at any step, at any time during this entire life cycle, but this has to be done. I mean, here it is compulsory. After this, if you continue doing EDA, that is completely fine. But at this stage, this step, pretty important. For me personally, I take up around 40 or 50% of the overall time. I spend half of my time for the project just understanding the data. Now this is an iterative process. So first I understand the data in the beginning, and then there is also a lot of error analysis that I do. So error analysis in terms of once my model has been deployed, what is the scenario? In which scenarios is my model working well? In which scenarios it is working moderately okay? And in which scenarios is it failing? So I do a lot of error analysis, I do a lot of EDA, and then I try to understand that what went wrong, why did it go wrong. Then I establish my hypothesis and then continue the overall project. But remember, guys, you cannot really afford to ignore this part ever in your pipeline. Okay, because this is what you are paid for. This is where you're going to extract all the intelligence and mine out the knowledge. So this is a part that you'll have to get extremely good at. The first part of being a good applied data scientist is to get good at EDA. Okay, and once you've done your EDA, the data preparation part, this is also going to be time consuming again, because the data will not always be in the format that you want it to be. Okay, and you will have to rearrange or manipulate the data in a manner that it suits the format that you require. Now I'll give you a very simple example. If you were given a task to parse through a lot of resumes, and I wanted you to find out that give me a set of people who've completed their graduation, set of people who've completed their post graduation, and what universities are they from. So this is going to be a pretty difficult task. Okay, I'll tell you, when you look at it manually, it is fine. But if you're doing data science, you don't want to go by manual route. So let me pause for a moment, and why don't you guys tell me that how will you approach this problem? Yeah, Adarsh, can you hold on to your question for a moment? I'll come to your question, but if we can probably answer this, how will you approach this problem? Check the education column in the resume. Okay, very good. Okay, education column. Okay, okay. What else, guys? Okay, keywords. Okay, Gaurav. Good. Yeah, scan words and compare to education and university. Okay, Karthik. Right, right, correct. So what you guys are saying is right. Now, the first thing is the way the resumes are designed, no two people will have the same format. Okay, there are very rare chances that you will find all the resumes in the same format. So first is parsing through the formats is going to be a difficult task for you guys. Sometimes you will have resumes with 2 or 3 columns. Sometimes you will have a flat resume with single column. Sometimes the education details may be given as academic details, and the way it is written is also going to be different. So I might write my educational qualification, name of the university, followed by the year. And sometimes I may write the college, then the university, then my degree, and after that, I will mention the start year and the end year. Sometimes it can be in the form of a table. So there are different ways in which things are written. So in your data preparation part, you have to ensure that you structure everything into a table. Person A, year, whatever it is when the graduation was completed, and university, and the highest degree, obviously. So this process of finding out and understanding is going to take up a lot of your time, the data preparation part. Okay, and here a rule-based, keywords-based search will most likely fail after a certain point. That's because if a rule works for one format, it is going to break for the other format. So think about how would you like to approach this problem from a data science perspective, guys. So I've given you one nice problem to think about. If you have to pass resumes and just find out the set of people who have completed their graduation, set of people who are postgraduates, and what are the different universities that they come from. Okay, if you ever get time, just think about how will you solve this problem end to end, right from your data collection to data understanding to data preparation. Deployment is completely okay. Let's say if you have to work on it locally in the Jupyter, what are the functions that you will write? Think about it. Homework for you guys. Okay, and once your data preparation is done, then you go for the data modeling part. This is where you will experiment with a lot of machine learning models. This is a pretty simple part. Okay, this you just have to pass the data that you prepared to multiple machine learning models and test the outcome. And after you have tested the outcome, okay, uh, again do a bit of error analysis and check data understanding on with respect to where did you go right and where did you not go right. Okay, now remember, data preparation, sometimes there are few things that you will miss. You may have to go back to data collection for some additional inputs. Okay, you may want to get some additional data. And after you do data modeling, you have to look at your model evaluation part. This is where you will do a lot of error analysis. And model evaluation basically looks at few parameters that are important for you and the business. So you always identify in model evaluation, you always identify where the risk is. So if I give you data to work on which deals with cancer data set or identifying cancer, okay, so you have to identify whether the person has or is a potential cancer patient. Now in this case, if I say the person has cancer and does not have cancer, is it okay, is it not okay? What do you guys think? If I predict the person has cancer and the person actually does not have cancer, is this okay situation to be in? Is it acceptable to the business as per you guys?
No.
Okay, I'll put it the other way around now. Now, if I say, if I predict the person does not have cancer, but the person has cancer, is this acceptable? Yeah, Meteorite, it's a false positive. Absolutely not. False negatives are a big no in this case. Okay, I can live with false positives. So, what business says is, if the person has a potential, if the person is a potential cancer patient, then we should be running some diagnostic tests. Okay, so now think that I have to perform a diagnostic test. So my machine learning model, now will I accept false positive? Am I okay or safe with say false positives or false negatives? I'm okay with false positives. Like there is always going to be an error. But what are the errors that I can accept and what are the errors that I cannot accept? Okay, so I cannot accept a situation wherein my model predicts the person does not have cancer and the person is actually a cancer patient. Okay, this is about life and death of a person. So I am okay to live with a few false positives. At the max, what's going to happen is the person is going to go through some diagnostic test and the test result will be negative for them, which is a good thing. Yeah, but you cannot afford to have a false negative here. Okay, when your business risk lies in false negatives, you look at a recall driven problem. So whatever models you're working on, it should be evaluated on the basis of the recall value of the model. Okay, and here most likely your recall should be, in this situation for cancer, my recall, I would expect it to be 100%, nothing less, nothing less, not even a point less. Yeah, because that is where the business risk lies. So business says, if I predict 100 people uh, as potential cancer patients, I want to ensure that I'm not losing out on everyone. If out of the 100, let's say 45 or 50 are my false positive cases, it is okay. I'm okay that the person does a diagnostic test, but I definitely don't want to miss out on potential cancer patient, because I don't want someone to die. That's how it is. And once you've selected the model and the performance is acceptable, this is again decided by the stakeholders during a business understanding meeting. Okay, that what is the acceptable performance. Then you deploy that model. So in the first iteration, what you deploy is something called as a MVP, a minimum viable product. So minimum viable product समझने के लिए imagine that you are moving into a house in an under construction building. So bare minimum क्या चीजें चाहिए आप लोगों को? You need the flooring done, electricity, plumbing, painting, at least these four things, and elevators if you're in a high rise. Okay, without this you cannot move into the house. Central park nahi hai, swimming pool nahi hai, chalega. You can live with it. Those are amenities which you can still live without. You can wait until they are being developed. But if the plumbing is not done, I would definitely not want to move into that house. I mean, I don't want to go to a mall and take bath in a mall every day or anything else. Yeah? Electricity, without electricity, obviously we cannot survive. So minimum viable product is something which comprises of bare minimum features that your model should have with an acceptable threshold of performance. Okay, and once you have that, you deploy it, and after deployment, again, you keep monitoring your performance and then iterate. So after monitoring, you get the new data, you retrain your model, check the performance again, and keep working on it. So once a model has been deployed in production, it is normally updated after every there are certain models which require more frequent updation because the data changes rapidly, and there are certain models which will be stable for some time, but around 7 months to 1 year is the life of one machine learning model before it is updated. Okay, so uh, the case where people think that once the model is deployed your job is done, you're wrong. You will have to reiterate and work on it. You'll have to constantly check that your model is doing well even in the current scenario, because as your business changes, your data will also change. Okay, and something that worked for you in the past may not necessarily work today. So which is why reworking on your model is extremely important. Deployment, yes, Karthik, there are chances that your code breaks, but before that, you have to do a lot of stress testing in deployment, and this is normally part of your DevOps and data engineer team. They will help you with stress testing. So depending on how many hits are you getting and what kind of volume can is acceptable, and if the volume increases all of a sudden, do we have the option to scale up or scale out? Scale up is like you increase the number of servers altogether. Scale out is just increasing the capacity of a very specific thing, like maybe a RAM or maybe a compute, something like that. Okay, so scale up mostly is in terms of your capacity. Scale out is talking about your capacity plus performance. Yeah, we can use Hive, Hadoop, that ecosystem, Spark ecosystem. The big data ecosystem works in this situation. Now, for most of the companies, you don't need big data. Trust me. Even when we started, we had no need of big data. But today, there is a need for big data. And after 3.5 years of the overall existence of the NLP and the software, NLP and the data science division, now we've moved on to big data. Okay, because now there is so much of data generated. We have our own data warehouse now to track and monitor things. So this happened after 3 years. Okay, so initially it wasn't there, and it is totally okay. So this data culture that we were talking about, there was a lot of data available, but again, not in the format we wanted, not the kind of data we wanted. So it took some time even for us to build the data. Now I can tell you for a fact that after giving 40 interviews, I got a break into episodes. So during those 40 interviews, I was able to get into a decent interaction with around 10 to 12 companies. And from the conversation that I had, there is one thing that I understood, that the company did not have enough data, or their clients did not have enough data. Okay. And I made a decision to not even proceed with the interviews, because if a company does not have enough data, and if they don't have a data culture, they are not serious about data collection, storage, and this entire strategy around building and saving data, then it is better you avoid it, because you won't be able to do much without the right kind of and right set of data. So these are things that you have to keep in mind. So this is what your data science project flow will look like. Is this clear to you guys? Yes. Okay. Okay. Perfect. Rohit, in the beginning, there is no need for you to have understanding of big data. Even if you don't know what big data is and its concepts, it's totally okay. When I joined, I did not know big data. I still don't know that much of big data, because it is handled by my data engineering team. Okay, I know a few things that I need in order for my model to be deployed. I take help of my peers, and I work with whatever limited knowledge that I have and that I need at the moment to deploy my solutions. So in the beginning, you don't know anything or everything. It's totally okay. You learn as as you start working on that specific project. Totally fine. All right. So yeah, my pleasure. Next thing is business understanding. So business understanding is pretty important. Now, this is where your domain experience comes into picture. So let's say if you already have some kind of work experience in a specific domain, then that is a big advantage for you when it comes to data science. Because trust me guys, when it comes to all these data science, machine learning algorithms, you never have to code an algorithm from the scratch. Okay, the basic algorithm without any hyperparameter tuning works for 99% of your cases. Okay, so things are almost readily available, so companies don't really want you to create or generate new machine learning models. What they want you to do is understand it and apply it and get the business outcomes. So the understanding of your business has to be there, because if you're deploying something which is not in line with the business strategies, or which is not in line with the domain that your company is in, then that can create a problem for you in terms of your future in the company. Okay, libraries will always work in deployment, Karthik. Libraries will always work. If it doesn't work in deployment, there is a problem with the deployment, not the library.
Sagar, how do you deal with updates of the libraries during production phases, and you need to keep updating them based on whatever updates are happening, because security loopholes might be there, patches
Hmm.
might be there, and all that.
Hmm. Okay, good question. So first thing is security loopholes that you're talking about. This will come into picture if your libraries are public facing. Okay, so most of the data science work that you do is going to be used for internal processing of the company and will not be public facing unless you're deploying an app that is public facing. So a lot of it is tackled during your data engineering part. You have a firewall or a web application firewall in front of your public traffic. Okay, so before a public IP, and when the data comes in from a public IP, it passes through a web application firewall. That is where most of your intrusions are taken care of. Now, when it comes to updating your libraries, you have to be absolutely sure that the libraries are stable. Now, this happened. There was an instance that happened with us. Pandas was updated recently, and in one of our libraries, we installed latest Pandas. Now it crashed because there was a bug in Pandas that no one had discovered before. There was a bug related to a grouping. So because of that, our production was down for close to 8 hours. So we had to revert to the previous version of pandas, and we only work with an environment that is stable. So before updating or upgrading, it is a good practice that you test it in an isolated environment, test a few files, and then start working on it. So your updates have to be very carefully chosen. Now, even if, let's say if you're updating pandas, there is a possibility you may need a higher version of NumPy. And if you work with a higher version of NumPy, there is a package that might break and not work well with the higher version of NumPy. So you will have to check for dependencies, and you have to ensure that one upgrade works well with the other dependencies. So
Yeah,
these are more of software engineering concepts. So this all has to be tested in an isolated environment, and you have to check the compatibility every time. This obviously can be automated, but without these checks, you can't proceed.
all right, thank you. Yeah,
Yeah, yeah,
I was
most welcome.
expecting that.
Yeah. Amit Morris says, can we create a virtual environment? Yes, Amit, you can create a virtual environment. But what happens is, even in a virtual environment, when you create a virtual environment, you will install one version of pandas. You cannot have two versions of pandas in a virtual environment, right? Now, the problem is about the other dependencies. So there are other packages that depend on pandas or scikit-learn or my NumPy. So if I update my version, then I have to ensure, yes, what are you saying? For testing, you can create a virtual environment? Absolutely. That has to be there. That is how you'll test in an isolated virtual environment. So we normally have a sandbox environment where we test things.
Sagar, another question. I wanted to check with you if what is actually better in terms of machine learning capabilities, Azure, GCP, or AWS? Or there's also Alibaba Cloud that's happening a lot nowadays.
Yeah, yeah. So Alibaba Cloud, see, frankly speaking, I'm not really in favor of any Chinese product or service. That's my personal opinion again. So if there is a choice between GCP, AWS, and Azure, I would prefer AWS right now because AWS is pretty matured when it comes to its cloud offerings and specifically cloud offerings for data science. Okay. Uh, Azure is pretty good when it comes to those software development related offerings. It is gaining, picking up pace in terms with what AWS used to offer before. Specifically for .NET and Python environment, Azure is picking up well. But AWS is a pretty matured market. The community is very strong, and their ecosystem is only getting stronger. So there are a lot of services when it comes to machine learning services, the machine learning ops, like DevOps, you also have an ML ops. Okay. So those services are pretty good that are provided by AWS. GCP, yes, it is getting there. Right now, that is not too matured. It has a lot of offerings. The feature sets are pretty high for Google. There is a lot of brain invested in the research part of it. But if you want a stable environment where you can scale up and scale out your production grade deployments, then AWS is my recommendation. Yeah.
All
So
right, yeah, I see the SageMaker is doing well, but
yes,
then ML Studio in Azure is also having pretty high capabilities, and some of them are being used by my company, and
yeah,
we are testing it out with SageMaker and ML Studio, and they do have competitive advantages for both of them, and
right,
they have an equivalent edge. So it was kind of hard for us to decide which one to go with. So
correct. So yeah, see, so when you do a head-to-head comparison of just ML Studio along with SageMaker, there might be a difference in features because every company wants to outlive the other and get more clients. But what you also have to check is how well does it work with your local environments. Now, from SageMaker, that studio, when you're training, how easy is it for you to deploy? And once it is deployed, how easy is it for you to interact and monitor things? So there are a lot of other aspects that you have to consider. And ultimately, I'll tell you, when everything is available for you, it ultimately boils down to business. I mean, how much money am I spending on this
right,
specific
right.
technology?
Thank you.
Volume is low. Yeah, most welcome. Is the volume still low? Yes, no. What about the others? Do you are you guys facing an issue with the volume too? Okay. Somnath, mind checking your speaker settings? Okay. Thanks, guys. Right. So business understanding. This is one area where I cannot re-emphasize and stress its importance more. You have to understand the domain, guys. You may not be able to understand it completely, but this is where your communication and your interaction with the external team members will come into picture, because you have to get in touch with people who belong to business, which means specifically the operation side, and get their help in understanding what your business is all about. And specifically, this will be clear during your data understanding part. Okay, this is where you'll deal a lot with the stakeholders that you're working on, and you have to ensure that you get a solid grasp on understanding the business and the domain. Spend some time even understanding your business and see what's going on in and around your domain. Next, the data collection part. Okay, so I'll tell you about our data collection part. So we had all the PDF saved in an S3 storage bucket. So S3 is AWS ecosystem. It's called a simple storage system. So we had a PDF flying in a lot of buckets. And for us, there are different kinds of projects or different kind of healthcare plans that our clients offer to the consumers. So we cater to our insurance companies who are our clients. So what we did is, when we collected the data, we had to ensure that the data had to be segregated in terms of the different healthcare plans. And even in a specific healthcare plan, there were different coding scopes. So sometimes some clients wanted data only for 1 year. Some of them wanted data for the past 2 years, so on and so forth. So we had to understand what the business was in order to ideate our data collection strategy. So there were some clients who required more information as compared to the others. So we had to segregate them in terms of different clients and the different coding scopes, and also the different healthcare plans. So even when you collect your data, don't just randomly collect it. Okay, try to keep your data segregated, because sometimes there is a possibility that there is a problem with the source of the data. Now, this happened with us in one instances wherein the client sent to us PDF files with extremely poor quality and low resolution images. So whenever it was converted into text, it was all gibberish. Okay. How many of you are aware of what OCR is? Optical character recognition. People have dealt with software before.
Yeah. Yes.
Yeah. Okay. Anyone who's not aware of what OCR is? Okay, Vikrant, so what happens is, okay, for people who don't know what OCR is, it's called as optical character recognition. Now, let's say, look at this slide, data collection. If I convert this into PDF and pass it on to my optical character recognition software, it is going to give me the text called as data collection in a text file. Okay, so this will convert all my PDF. So PDF is nothing but a kind of a portable document format or an image, and it takes all the text and gives us the output in an XML or a JSON file, and from there we get the text. Now, if this image quality is low, uh, then what's going to happen is this data will become OAT, and then there will be some gibberish character, and collection will be totally lost. You'll lose the meaning and sense out of that document. Okay, so the reason for segregating your data collection also has to deal with understanding how credible a specific source of data is. Sometimes if you get a client whose PDF images are pretty bad, then I might have to take a call that I will not really be able to work with a specific data. So I have to set a benchmark and expectations to my stakeholders as well, that if you want us to perform NLP, then the data, when it is OCR, it has to have certain amount of quality threshold, which means the images have to be clean, right? So even when you collect the data, you have to look at is there a specific source of data where, I mean, most of the data is null. If that's the case, then you probably go back to the person who's handling the data and ask them to either clean the data or get the data in the right format, or maybe disregard it completely. Because if you collect wrong data or data that is so bad that it cannot be cleaned at all, it is better you don't even have that data in your source. It will unnecessarily disturb your entire machine learning pipeline. Okay, so once you have the data understanding is pretty important. So we understood that it is not just about the technical part of the data, but also what it means in terms of business. Now, let me take a couple of examples of data understanding. So, data understanding is a combination of a business along with a specific domain knowledge. Now, when we started showing all the highlights, okay, you remember I spoke about NER, name entity recognition. So, what we do is we identify diseases in a chart and we highlight them and show it to our medical coders. So, now instead of going through 1,000 pages chart, what they do is they just look at the highlighted components and that saves their time. So if there is a page where there are no highlights, they skip those pages and they look for the other pages. In fact, they only look at pages that are highlighted with diseases. So that way we were able to save around 35 to 40% of coders time, and that's where the overall optimization was done in terms of time. The first business objective was met, and obviously the second one, which is still ongoing, I mean using NLP, but now we're using it in a much better way. So when we started highlighting, we realized that sometimes we end up highlighting a few extra diseases, and sometimes we end up missing a few valid diseases as well. So that's a kind of false positive and false negative for us. So in data understanding, you also have to realize that what kind of false positives and what kind of false negatives can be there, and what is accepted and what is not accepted. Now, when we were working on the false positives, okay, so we had two different strategies. One was to reduce false positives, and one was to uh, reduce the false negatives, or rather increase the coverage. So when we started working with false positive reduction, that is when we realized that there are certain business, or rather domain specific rules which apply to a certain set of charts. Now, because we had a clear distinction or demarcation of the data source coming from different clients and healthcare plans, it became pretty easy for us to apply those rules. So when, let's say, if we had healthcare plan A and the data comes from that healthcare plan, there are specific set of rules because of which certain diseases are not really passed to the insurer for reimbursement. Okay, so we delete them. So that way we are also able to reduce our false positive by 62%. Okay, when I say 62% false positive reduction, it's a massive improvement, guys. And it took us around a year and a half to get there. The development and designing of rule engine itself was pretty intense. So this happened because we had a good data policy. And when I say data policy, it was the data collection and the data storage policy. And because we also started gaining understanding over a period of time. So everything did not happen when we started. So there were things we realized across the way, and this is going to happen with you as well. Okay, there are certain things that you will realize can be made better across the way. So machine learning or data science is always an iterative process. So you have to revisit a problem over and over again. I'll tell you one very interesting problem that we were able to solve very recently. So sometimes you have these forms and check marks in a form, right? So there will be a list of check marks, and then you'll have the name of disease beside it. Now the OCR softwares will 99% of the time not capture check marks because it is only concerned with the text. So to detect the check boxes, or maybe the radio boxes, uh, you need something called as OMR, optical mark recognition, whether the checkbox is checked or it is unchecked. So there's a different set of software. Okay. So what we did is, now we combined computer vision and NLP, and we found out that which are the entities that are checked. So this is a custom component that we integrated into NLP, computer vision for NLP. So this is just to identify checkboxes and whether the checkbox was checked and what was the value associated with the checkbox. And this way we were also able to eliminate false positives from the checkboxes, because there were certain instances wherein we used to get a page and the doctor used to ask, have you suffered from any of the following diseases in the past? And there used to be a list of 100 diseases. So this happened when our COO got a shocker. So we sent him a process chart. We told him that there are 100 diseases, and even we felt it is counterintuitive. A person cannot suffer from 100 diseases, and if he or she has 100 diseases, it is difficult that the person will survive. Okay, so that is when we realized that this is the kind of problem we are running into. It was a very rare chart format which we had never come across. So there are a lot of things that you will realize and improve along the way, and that's when you keep adding components into your pipeline and keep making your overall data science product better. Okay, but in order for you to go there, your initial MVP has to be in place. Your data collection and data understanding has to be in place, because you don't want to spend time into data segregation and formatting your data every time. Okay, so you set those policy once, and you should have the flexibility to make minor arrangements, because if you spend up another 3 or 4 months just with additional data collection and reformatting the data, you will lose a lot of precious time. Okay, now things like this that I spoke about, clients need it rectified immediately. Okay, or if not immediately, maybe that should be the top priority or the next project, something like that. So which is where understanding of your data and the domain will help you. So because we gain that understanding of the domain, that if there are questionnaires like this wherein the patient has to tell what he or she has suffered from in the past, that is a kind of disease that a medical coders do not accept. They only accept a doctor patient interaction and capture the diseases that the doctor has validated. Okay, so that so data understanding is ultimately your business and domain understanding. And again, guys, these questions, these are the kind of things that you will have to get in touch with the external team members. Your data science team will be extremely good at the mathematical, statistical, and the coding part, and the DevOps and the data engineering part, obviously. But there are people who are experts at the domain, experts at the business. You have to take their help. You cannot be a one-man army in this.
Sagar,
Yeah.
I'm sorry to interrupt. I just want to take a few seconds. I'm launching a short poll on the screen of the learners.
Okay. Okay. Sure.
Guys, I've launched the poll on your screen. You will see it on your screens now. It's just a couple of questions. Just quickly take it. I think we are 45, 46 of learners here. I think everyone has to take it. Thank you, guys. I think some of them are remaining.
Okay. We'll wait for some time. Let me know once everyone is.
Yeah, sure, sure. Just 5, 10 more seconds.
Yeah. Sure.
Great. Thank you, guys. Thanks for taking the poll. Sagar, you can continue.
Okay. Thanks, Vijay. Right. Data preparation. So guys, this strategy is important so that you don't have to do a lot of dirty work afterwards. Repeat it at least. Okay. This has to be done once. Maybe there are few additional data points that you'll have to collect in the future, but it shouldn't take as long as it did in the first time. So data preparation, this strategy is crucial for you in terms of the turnaround time of a project. Okay, a project will never have endless amount of time. So when we started with our data collection or the data preparation strategy, we had to understand how will the PDF be converted to XML, and how will the we extract text. Okay, there are a lot of nuances and little things that need to be taken care of, specifically things related to table parsing or form parsing. So there are a lot of things that we had to take care of. Now this is a strategy that we decided initially, and then what we normally do is we capture everything. We capture all the information. So for example, if I'm capturing a text from a PDF, I will capture what are the coordinates. So from the what is the distance from the top, what is the distance from the left in terms of my text, what are the coordinates, where does it start, where does it end, everything. So we capture all these details and we log it somewhere. So tomorrow we understand that if we have to use these details and try to analyze a few things, we will get an idea. So that will go a long way in helping in the future. So all these changes that we have to make in terms of the checkbox identification and mapping, the previous data collection or the way we prepared and strategized our data and the data points that are being saved, that helped us. Okay, so including a
Yes.
new component. Yeah, tell me.
I just wanted to check, why do you need language processing to recognize check boxes or radio buttons when you already are having computer vision to analyze that?
No, I never said that we needed language processing to identify checkboxes.
No,
So
you said computer vision with NLP.
yes,
I thought NLP is natural language processing.
yeah. So we use computer vision with NLP. It is not computer vision for NLP. It is computer vision with NLP.
Yeah, my question. Okay, understood now. All right, thanks.
So one portion is identifying checkboxes and or let's say any other CV component, let's say table or checkboxes. I'll stick to checkboxes. And there is one component which deals with my language. Okay. So I have a NLP model that identifies my entities of medicines, and I have a component that identifies my checkboxes. Okay. So with CV, I
Yeah, got it.
identified
Yeah,
checkbox.
thanks.
Yeah, but what is required is a logic to map them. If I have 10 checkboxes and if I have 10 diseases, how do I know which checkbox is mapped to which disease? So that's where the data preparation strategy comes into picture, right? So if I did not have the coordinates of my PDF, that what is the distance from the top, what is the distance from the left, and if I did not have those start and end offsets, it would have been difficult for me to map it. Understand? So see, if I have 10 checkboxes, but I cannot map the 10th checkbox to the first disease, right? It has to be, they have to be on the same line. Do you get that point, guys?
Right. Yeah.
Yeah. So the distance from the top will help us. And even the distance from the left. There is also a possibility I will have two diseases in one line. It could be like a column. So that way, so which is why when you are creating this data preparation strategy, you should identify the data points that will help you in the future. And it is okay for you to collect some additional data, keep it, because data will never go waste. Okay, you will utilize it at some point or the other. Now, there is one thing which really helped us in this is when we were capturing the coordinates, there is a process of identifying the document heading. Okay, we also capture if the text is in bold or if the specific text font size is more than maybe certain amount of pixels. So with the help of that, we had a pretty simple rule-based strategy wherein we tried to identify section and document headings. Okay, and most of the times the document headings were within the first 25% of the page. So I understood that if I have a bold text within first 25% of my page and it contains certain keywords, so that talks about a document heading. So this way, at least we were able to cover 45 to 50% of the document headings with a close to 96% accuracy. So even that is being used a lot in terms of identifying whether a specific piece of page that we are working on, is it valid or is it invalid? So if it is like some kind of a insurance file or some demographic details, we ignore those pages. Okay, so remember guys, what are the things that are available with you? How can you use them? These things matter a lot. That is why the understanding in this case, these technical understanding of the data will help you, but you have to connect the dots with the business, right? Does this make sense to you guys? Did you guys get the example that I'm talking about?
Yeah. Yeah. Do you also have any case wherein you dictate what kind of templates the client should be having? Because you might have multiple clients. So maybe having certain type of templates will help you
Yes.
read the data science and read documents easier.
We wish we could dictate that template, but unfortunately that is a choice we don't have, and that is where the overall power of data science comes. So the system that we've built is robust to template, so we can say that our clients need not worry about the templates. They can bring in their own format that they have been using, and we'll try and work on that. So we have built a system that is generic, because clients will most likely not agree. See, if you're working with a client, the client will tell you, this is what I have, if you can work, good enough. If not, that it's okay. Okay, so especially with these kind of medical report formats, you will not have a choice. The clients will use what they want to use. They will use something that is easy for them to use. So there are a lot of EMR softwares available in the market. It's called as electronic medical records. So a lot of companies, hospitals, they use them, and they have their own preferred vendors for whatever reason. Now they will not change that because we cannot process something. So they will say, this is what I have, and read it, work on it.
No, no, thank you.
Yeah, well, so book with real world use case and their approaches. So see, things like what we are doing in a production grade environment, this experience will come with production environment. What you can do is you can start a small open source project, and then you should give objectives to yourself and try working on it. This is as close to a production grade project that you can come to. Okay, and there is no book that will give you a production grade knowledge, which is why you always need mentors, and which is why you need practice. So pick up any book. In fact, in this book from Aurelian Geron is what I recommend to people. Hands-on machine learning with scikit-learn and TensorFlow. That's really good. So work with that.
Sagar, can you explain vaguely your production environment wherein you're having the components do the tasks? Like, is it like a continuous changing environment in the application, or it is only event based, or maybe like you have this
We
call
deal only
center?
with no, we deal only with event-based triggers. So what we do is our files are processed in batches. So we have 2 batches running per day. So we create or spin up the AWS instances, uh, at the time when the processing is supposed to be done, and once our processing is completed and the data is saved to the respective folders or S3 buckets, we destroy the clusters. That's what we do.
All right, yes, and saves money as well when you destroy the
Absolutely.
clusters, right?
Yes,
Oh,
yes.
got it. Thank you.
Welcome. So data modeling, I guess this is a part where you don't need to, think a lot. Here, your software engineering skills will come into picture, and more than engineering, I would suggest if you're able to write a small piece of code that will automate the uh, data testing for you, you're good to go. So let's say you've got a tabular data. Now you have to select a model. So all you have to do is divide the data into train and test, instantiate models, and just create a pipeline which will first run through logistic regression, then random forest, then XGBoost classifier, then a voting classifier, and then you check the result. So if you create a script which will automate this test for you, you just have to wait until you get the result. So this is the part where your efforts are going to be least, the data modeling part. Okay, so data science, and as the name suggests, not everything is data science. Things are more related towards your data cleaning and pre-processing and collection, business understanding and communication. This is hardly 5% of the overall task. Okay, that's a harsh fact, but that's how it is. It is not as glorified as people make it look like. But if trust me, you should enjoy doing all these things as well, because your data modeling part will give you good results when you've done everything else in the past well. All that we spoke about. So here you just have to create a pipeline where your machine learning, where you have multiple machine learning models, and you capture the results. And once your results are captured, then you finally decide that this machine learning model with certain set of parameters is giving me the best result, and I'm going to take that model and deploy it. This is all that is supposed to be done in machine learning modeling. And what you do after that is evaluation. Okay, I have a question. How different is real-time data analytics, as in what should be general tech stack for handling that? So tech stack is pretty much the same. For tabular data, I still use scikit-learn. Okay, for NLP, I use Spacey. Uh, then for the computer vision problems, I'm using OpenCV. So these are all the basic stacks. If you look, there, people will talk a lot about deep learning and advanced hyperparameter tuning. That is frankly speaking not required. The way these machine learning models are created, a lot of research has gone in, and even the general parameters will work. Even if you have to tune hyperparameters, it is not a big task. It is time consuming, but you just have to create a pipeline for that. Okay, so keep your tech stack as simple as possible. Remember, guys, the most efficient solutions are the ones that are simple in nature, and they are very difficult to create. So if I ask you to create a solution and keep it as simple as possible, it is going to be very challenging for you. Adding complexities is like adding patchwork. Okay, when you run into a problem, that is when you will realize the importance of keeping a solution simple. Okay, for example, we have a requirements.txt file. So whenever we build an environment for processing our data, we have a requirements.txt file wherein we understand that what is being installed on every component of the cluster or every slave of the cluster, and then we also log every errors that we get. So that is where we were able to understand that it was an issue with the pandas. So we first identified that which process had suffered, and after that, from that process, we understand that where is this process or function being called from. Then we understand it is called from a certain package. So what went wrong with the package? What were the changes in the package? And did this package work properly for the past 4 or 5 days? Was there any change in data? If not, then what had changed? And then we realized that in the requirements file, we did not mention the version of pandas, and that created a problem. Okay, but because our stack is so simple, these are things that we work with daily. Okay, I did not have to change my pandas function. I did not have to look at my code base at all. I just had to uh, uh, track the backtrace it. And I realized that it was just one issue. We had to add the pandas, most stable pandas version in the requirements file, and everything was up and running smooth again. So the more simpler your solutions are, more easy it is for you to debug, and more easy it is for you to get better at. What you should be really focusing hard on is your entire data strategy, right from collection to processing to storage, and how are you going to analyze that information. Analysis, obviously, understanding business data analysis. Two things is what makes you money in data science. And obviously communication matters a lot as well. That's for your growth. Okay, so stick to the basic tech stack that is easily available. And if you work with a stack that is readily available, you'll have a community help. You'll have Stack Overflow. You can check with people on Reddit, or maybe anyone else who's experienced. They will help you. But if you're building something all by yourself, the only one who can help you is you. And if you're stuck, you're stuck. Okay, finally, it's model evaluation. So this is where you will understand that what went right with your model and what went wrong with your model. You identify things that did not go well and understand that why things did not go well and rework on that. Okay, you don't aim for 100% accuracy with everything, but at least try to ensure that there are no stupid mistakes. So try to ensure that you don't end up with any kind of a silly mistake or so, and also that there is no disaster. So this is what your model evaluation and your error analysis will help you with. Okay, and finally deployment. So you can create an API for your deployment, or maybe you can just create an installable package the way you feel it's comfortable. So this will come with time. Don't worry about deployment, guys. This is the last step that you should be thinking about. So first, you should get these existing things, the existing components that we spoke about, all the prior components. So I'm going to start here again. So business understanding, data collection, data understanding, data preparation, data modeling, model evaluation. This, these are the steps that you should be focusing on first. And once this is done, you will have help with deployment. Okay. And then the reiteration is like improving your model.
What are the SaaS applications that you use right now in AWS? Like if you give us like an overall big picture.
So we use SageMaker for our training, and we have a queuing service from Redis. And once that is done, I guess all the systems are queued in the master, all the files are queued in the master. Then we've got around 5 to 6 slaves. And after that, for processing, we have our own custom installable pip packages for all the components which are installed. And once that is done and the processing is done, we store everything into an S3 bucket. A lot of the things are logged into a data warehouse, which is again on AWS, their inbuilt warehouse. And after that, the cluster is destroyed. There is one tool that we use which uses Aurora DB in the backend, and the front end is built on Flask. So that is used specifically by our domain experts. We have a team of domain experts of 3 people who feed us the domain related knowledge. So we've given them a front end to make the corrections, and we normally pull data from the Aurora DB specifically for our rules based engines. So that's our
All right,
360.
you guys don't use Redshift, is it? I
Yeah,
mean,
Redshift it was. Yeah, I forgot that. It was Redshift, the queuing service.
okay, you guys have a data lake there
Uh,
to pull the data into Redshift.
No. We don't rely on data lake. So it all comes from the S3 itself. So whenever we have to process a set of charts, it is pushed into an S3 bucket, and that's where we pull the data from. So this S3 bucket is attached to something called as a there's a concept of EVL, elastic volume or something. So it basically expands as in when your data increases.
Yeah, outscaling. I mean,
Outscaling, yeah. So I can't remember the name exactly. So there are different kind of volumes available. So when you have to attach a storage to your AWS compute, there is a normal storage available, and then there is a elastic scalable storage that's available. So
EC2.
no, EC2 is the compute. From a storage perspective, there is one storage which is fixed, and then there is a EBS or something called I can't remember the name exactly, but it's a
Anyway, understood. Yeah,
yeah. So that volume, what happens is it is like a dynamic hard drive. So
elastic
the
storage. Yeah,
century drive, yeah, it keeps expanding as and when your data increases. So,
auto scaling.
yeah, EBS, correct, man. So
Thanks.
finally is, yeah, most welcome. Finally, it's all about dealing with stakeholders. So when you have your results ready and when you've made progress, you talk to business and your stakeholders about it. Again, you don't talk to them about your deployment strategy unless the person is technical and wants to know about it. This will most likely be your CTO or your principal data scientist. And you always focus on the business outcomes and the impact that you created for business. So in the first version, we spoke about the kind of impact it had on time. Okay, since the company was interested in reducing the overall time, so initially we were able to reduce around 7 to 8% of the overall time, and now we are like around 45 to 50% faster with the help of overall strategy. So you always talk about the kind of business impact that your machine learning or your overall data science project has created for the organization. That is what you talk to stakeholders about. So people who were a part of my 5 day workshop, I'm not sure how many of you present here have been a part of that. So there was a presentation that I had given, which was like around 15 minutes presentation on the slides that you should be presenting to stakeholders. And you, even if you have to talk about things like a precision recall, don't use that. You just talk about where the business risk is, whether it is in false positive or false negative, and with the current with the current model, how are we covering that risk? So with stakeholders, the talk is just to and about business, anything but business. Right? So different type of stakeholders that you will deal with. First is the business team. This is majorly your operations team. Engineering is basically your data engineering team for people who are in data science projects. You will most likely have a data engineering team to support you. If you don't, then these are things you'll have to handle by yourself. If you get to do that, trust me, you guys are lucky, because the demand for data engineers is going to rise as well because of data science. Okay, we've got so many data scientists. The demand for data engineers is going to increase equally well. And if you have knowledge of both data engineering plus data science, so that's like a full stack data scientist. So previously in software development, we had a full stack guy who knew about the backend and the front end. So someone who's able to use Node.js and React.js, or probably uh, Python along with Flask and HTML and CSS. And for data science, it is going to be all the data science concepts, everything we spoke about, plus the data engineering concepts. So that's a full stack data scientist. They will have a lot of demand. They already have a lot of demand. Uh, we don't have good full stack data scientists across the globe. So try and build this portfolio out for yourself. Have some basic deployment knowledge, if not full fledged, but try to get that. Okay, I've been trying to do learn that through my organization. There was a bit of Hadoop and Spark that we learned during my days at Grey Atom. Okay, we also had a deployment session on Flask, which was taken by my boss. So try to have at least a basic understanding of that, because that will always be helpful for you guys. Okay, and yeah, Docker as well. Docker is something you should be focusing on. I'm learning it myself. Leadership, guys. So this can be either your principal data scientist or your immediate team manager. And this can also refer to your C-suite guys, your CEOs and CFOs and CXOs. So if you've had a major breakthrough with the help of data science, then obviously this is something which you have to present to them. Okay. Now, I can tell you from my experience that during my previous job, I used to design a lot of backup strategies. Okay, so Just Dial overall pan India backup strategy. I was a part of the design and implementation team, and I was also into intense discussion with the SBI mutual fund organization. So they were working with some people on their data science strategy, and that is when I was a part of the storage design team, designing an RFP for them. So at that point, I'd seen a group of people presenting to the vertical heads. Okay, and the questions are pretty shrewd and all related to the domain and the business. So when you're dealing with leadership, ensure that you have a decent amount of understanding about the business and the domain. How Docker images will work with DS. So when you create a model, okay, sometimes your model will have certain dependencies, and if you don't expect people to install dependencies every time. You can just create a Docker image. The person can uh, query the Docker image using an API and get the result. So read more about it, Karthik. Yeah, correct, Krishna. Microservices is also one thing, but at least a basic deployment is what you would require. So when you're starting with your data science journey, Mahinder, not really required. But as in when you advance, you should start getting an understanding of all these things. In the beginning, all these is not required for you. Okay. Then the stakeholders are your managers and your team as well, because you will have to work within your team. So you have to communicate efficiently with your team and your manager, obviously, because your manager is the one who is going to be after you to ensure that your project is completed on time. And he or she will also ensure that whatever help is required for you to complete the project from your team is given to you. And ultimately your clients, obviously if you are a services based company, your clients will matter a lot to you. So you will have to be in constant touch with them, regular updates, and showing incremental positive changes every time. Remember, like I mentioned earlier, data science is an iterative project. You are not going to be able to build a perfect system in the first instance. Don't even run after it. Okay, make steady incremental progress. That is what is required. So, things that ensure effective cooperation, communication, prioritization, mutual goals, and consistency. Now, mutual goals is something which I will put it in the first place. So, during our initial discussion during the business, the goals are set here. Okay, so first set of goals related to business are set here, and the second one, and how do you go about delivering this entire data science project, is done within the team. So ensure that the goals are well understood and everyone in the team is in consensus. Second, communication. So communication is in terms of both your current progress. If you are stuck somewhere, communicating that as well. If you have had any kind of incident, creating an incident report, logging it. So communication also deals with logging and stating facts. Okay, sometimes communication also deals with handling conflicts. So as a business manager, the person may have their own preconceived notion about the business. Okay, but sometimes what you find in data is very counterintuitive. Now, what happens is you can't just say, no, this is what it is. When you start with a sentence and you tell like, no, this is what it is, this is what I know, this is correct, what will end up is you will end up in a conflict. This is not a good thing. So you have to state facts and you have to present the facts in a very respectful and a professional manner. So trust me guys, this will happen a lot with you during your data science communication meetings. You will find something, business will find it counterintuitive. Okay, so handling conflicts is going to be one thing which you have to learn about, even with your manager. Sometimes your manager feels that a project should be done in 5 days, but you feel it's going to take 7 days, so you tell them the data collection takes X amount and the processing takes X amount for whatever reasons, but you have to state facts, okay? And you put it across. You make your point and put it across. That's it.
How do
This
you decide how much time it takes for the data collection in this scenario? I mean, even though it depends on the problem statement, how do you quantify the data collection
So you
stage?
first work on a small subset of data, and then you estimate a time on the basis of that. It's as simple
All
as that.
right.
So it's a
Okay,
simple
thanks.
statistic thing. So sampling is what you will help here, and your sampling again has to be unbiased. So while you, let's say, if I had to deal with a lot of charts, I will first need to understand what are the page ranges in my charts, and I'll have to ensure that I take equal amount of charts from all the respective page ranges.
But let's say you have data coming in from multiple sources and it's across the organization and you don't have the right pipelines to get it. And what if your data collection gets slower because you do not have, I
That's why
mean, you do
initially you
not
have
have,
to work with a subset of data. You always start with subset of data that will give you a good estimate. Again, it's an estimate.
right. Okay, yeah, understood.
No one is going to hold you to it. No one is going to hang you.
Right, right. Thanks.
Yeah. Okay. Prioritization. This is pretty important. So when you guys get one business objective, you will normally have to break it down into smaller machine learning problems. Okay. And then you have to prioritize which one is supposed to be done first. So let's say when you're just starting your journey, you understand that data collection is going to be pretty important in the beginning. So you focus on that first, or data manipulation, or the EDA. So you prioritize your task on the basis of which stage of journey are you in and the criticality of the situation. So this is something which will come to you with practice. Okay, I can only talk about my experience and give you gyan on it, but priorities, how to set your own priorities, will only come to you with experience, even for your own personal projects. Okay, so now imagine this learning is a priority for you. So now even if you ask me as a student what would be my priority, a priority number one would be to apply things that I have learned effectively. I don't want to learn everything at one go. Whatever I have learned, I want to apply that. I want to be able to apply that. That's it. And second thing is, whatever I have learned so far, how do I apply it and how do I ensure that I remember it? So I need to practice. So my priorities are application of whatever I've learned, practicing whatever I've learned so far, and whatever it takes for me to practice, maybe a GitHub portfolio or maybe a blog, whatever helps me. So that's how you define priorities even in your learning journey. Okay, and this will only come when you start working on it. So we spoke about mutual goals, consistency. So like I mentioned, one big result and then you go dormant or silent. So that's like a volcano. Okay, it erupts once and then you go silent. No one likes that. You have to show small but consistent regular progress. That is what is appreciated in the data science team, and that is what is expected as well, right? So this is it. We've got a couple of minutes if you have any questions for me. Oh yes, that link.
Also,
Are we
Sagar, yeah.
one second? Vijay, are we going to share this presentation with them?
Yes, yes. The presentation and the recording will be shared with them.
Okay, perfect. So Ramesh, you have the link in this presentation itself. It's on slide 2 or 3, I guess. I can remember the slide number, but check. The link is over there. Yeah.
Oh, yeah, guys, I'm gonna share that. Yeah.
Oh, Krishna, go ahead.
Yeah. So, what are the latest developments happening in the field of data science as of now?
So see, when you
Like
say
cutting
data
edge. I
science,
meant
so see, data science
cutting
is pretty
edge.
broad. Data science is a very vast subject that you're talking about.
Right.
In data science, you've got computer vision, you've got audio, you've got video, you've got natural language processing, you even have tabular data. Then,
Agree. Agree.
so
No, I meant like according to you, what do you think is cutting edge? Happening right now or going to happen,
okay, so
or what being worked on right now?
I'll
Because
talk
what
in
I
terms of
perceive may be
NLP.
different from yeah.
Yeah, absolutely. So see, everyone will have their own perceptions, but I'll tell you, since I work a lot on NLP, uh, GPT-3, I guess that is the most spoken about, talked about things these days. So it is trained on like 375 billion features, and it should automatically be able to even label or classify data without any training data. That is what they claim. So this is the buzzword in my area of interest these days. People talk a lot about GPT-3.
Oh, nice. All right.
Yeah. So you pick up an area of interest and start following people on Twitter and follow this website called as Papers with Code. You'll see some or the other person who will have published some kind of a research paper and along with the code. So that's how you keep in touch with them.
Okay. Thank you.
Yeah, most welcome. Cool. Thank you so much once again, guys. I hope you were able to take something informative and valuable out of this session and out of all the experience I've shared with you. Ramesh, OCR and PDF reading is all about a software engineering practice. Uh, there is a open source package called as Tesseract. You can read about that. Again, that's more like a computer vision. Yeah. Thanks, Vijay. Well, thank you very much, guys. I don't want to spoil your Sunday morning anymore. People who woke up early in the morning just for the session can go back to sleep. I'm going to do that.
Yes, Sagar, I can. Thanks, Sagar. Thanks a lot, guys, for
Thank you.
attending the session, and thank you for attending on time. So it's really helpful that you guys participate and make the session interactive. Sagar, thanks for the wonderful session. It was great.
It's my pleasure.
I'm sure the learners liked it. Guys, please share the feedback. I've shared the feedback form with you. Please fill it. And we'll see you next Sunday with some another amazing topic, another interesting topic in session with the mentor. Thank you, guys. Enjoy your Sunday. Thanks, Sagar. Enjoy your
Thank
Sunday.
you.
Have a nice sleep
Yes.
if you
Yeah. Thanks.
didn't complete it. Thank you, guys.
Okay.
I think we are good to leave the meeting now.
Okay. Okay. Perfect.
Bye, guys. Thank you.
Bye.
Thanks, Sagar. It was really good.
Yeah, thanks.